Question 8a. Here are the fourth and fifth terms of a Fibonacci type sequence. Each term is the sum of the previous two terms, and we need to show that the first term is 2. So that term add that term gives us that term, this term and this term gives us this term, and this one add this one gives us that one. So if we work backwards, 43 take away 28 should give us that term there. So 43, oops, try again. 43 take away 28, and that gives us 15. So that one there is going to be 15. We're then going to do 28 take away 15, and that is going to give us that term there, which is 13. And then we've got 15 take away 13, which gives us 2. And that's going to give us that term there. Okay, so part B says here are the first and third terms of a different Fibonacci type sequence. So the first term is A and the third term is B. Each term is the sum of the previous two terms. Like before, we need to work out an expression in terms of A and B for the fifth term. So A plus this term here gives me B. So like we did before, we can work backwards, and if I do B take away A, that would give me this term here. In the same way, 15 take away 2 gave me 13, or 28 take away 13 gave me 15. B take away A is going to give me this term here, so we can just call that term B take away A. And if I sum these together, I would get B, so that works. Okay, so now we can add these two terms together to give us this one. So B take away A plus B is going to be 2B take away A, and then B plus 2B take away A is going to be 3B take away A. And that's going to be our expression over here. It's going to be 3B take away A for the fifth term. Okay, question number 9. Noah is attempting to work out the base of different right angle triangles. Here is his method for working out, here is his method with the working for y is equal to 10 and x is equal to 6. So the y is the hypotenuse and the x is one of the shorter sides. So to work out the value of y squared, we do 10 squared to the 100, x squared is 36, and then we do that squared, take away that squared, it gives us 64, and then if we square root that, we get the base is equal to the square root of 64. So we need to decide which of these statements is true. This method would always give us an answer which is a whole number, or sometimes give us an answer which is a whole number, and will never give us an answer which is a whole number. Well, the first thing we need to do is decide, well, what is the square root of 64? Well, the square root of 64 is going to be 8. Okay, so we can already see that we've got an answer that gives us a whole number. So this one can't be true. Never a whole number can't be true. Okay, so is there a situation where I can choose a value of y and x, which is going to give me something that isn't a whole number? Let's try it. If I said y is equal to 10, and let's let x equal 3 this time. Okay, so if y is equal to 10 and x is equal to 3, then we're going to have 10 squared is going to be equal to 100, and 3 squared is going to be equal to 9. 100 take away 9 gives us 91, and the square root of 91 is, well, we can see 91 isn't a square number. Square root of 91 is not an integer. It's not going to be a whole number. Okay, so that means that it's only sometimes going to give us a whole number. It gave us a whole number over here when we had the square root of 64, but the square root of 91, it wasn't a whole number. So I'm going to tick that one there. Okay, question number 10. The diagram shows 3 routes A, B and C between the towns X and Y. The distance and average speed for each route is shown. So route A has a distance of 25 miles and an average speed of 50 miles per hour. Route B is 20 miles at 30 miles per hour, and route C is 30 miles at 40 miles per hour. Okay, part A says which of the 3 routes takes the longest time, and we assume that the average speeds are given here, and we need to try our working out. So for route A, to work out the time, we want to do so time is going to be equal to, we want to do the number of miles divided by the speed, the distance divided by the speed, which is going to be 25 divided by 50, which is going to give me a half an hour. Okay, and that's going to be equal to 30 minutes. Okay, for B, we've got our time that's going to be equal to 20 divided by 30, which is going to be equal to, that's going to be the same as 2/3 of an hour, and 1/3 of an hour is 20 minutes, so 2/3 is going to be 40 minutes. Okay, and then for route C, our time is going to be equal to, and this time we've got 30 over 40, which is equal to 3/4 of an hour, and 1/4 of an hour is 15 minutes, so 3/4 of an hour is going to be 45 minutes. Okay, so which of the 3 routes takes the longest time? It's going to be route C, takes longest, and which is 45 minutes. Okay, so C. Okay, John and Matt take the same time to travel from X to Y. They take the same time. John travels along B at 10 miles per hour faster than the average speed. So the average speed is 30 miles per hour. John must travel at 40 miles per hour. Okay, Matt travels along route C, which is this one here. And where we're being asked, does Matt travel faster or slower than the average speed for route C, and by how much? And we need to show our working out. So first of all, we know that John travels along route B at 10 miles per hour faster. So for John, he must go 20 miles at 40 miles per hour. So the time for John is going to be equal to 20 divided by 40, which is the same as a half an hour, which is going to be 30 minutes. So it takes John 30 minutes. John and Matt take the same time, so it must also take Matt 30 minutes as well. Okay, so if it takes Matt 30 minutes to travel 30 miles, then Matt's speed must be, or it takes 30 minutes to travel 30 miles, so he must be going 60 miles per hour. Okay, 30 minutes to travel 30 miles means that he must be going at 60 miles per hour. Okay, so Does Matt travel faster or slower? Well, he travels faster because the average speed is 40 miles per hour. He travels faster, and by how much? Well, if he's going 60 miles per hour, that's going to be 20 miles per hour faster.